It's happy Monday again. Hope you had a good weekend. It's actually like kind of nice with some sunshine, right? Wasn't too bad. Anybody do anything fun? Work? I asked if you did anything fun. What'd you do? Oh, okay, nice. Happy birthday, or belated birthday. Should we sing? You sure? All right. No one ever takes me up on the offer. No one's ever been like, yeah, sing for me. Uh, so more work on arrays and vectors today. We're going to look at how we use them in functions now, which is super fun because functions are great. We love functions. Uh, Vectors are super easy to use. Arrays, not so much. Another reason I just think arrays suck. Again, I've got opinions. I'm sure you've noticed. So that'll be cool. So we'll work on that. And we're also going to look at doing two-dimensional arrays, an array of arrays, or a vector of vectors. It's lots of fun. So it's another fun way to think about things. And we'll do our lab today, and then we'll wrap up vectors, have a little more time to work on project 3 on 11.8, and then we pick up objects and classes. We spend a week on that. Then we have Thanksgiving break. This comes a little early this week, or this month, right? It feels like. This is November 2nd was the Thursday. So a little early in the month. And then we come back end of November, talk about pointers, and that is the last new topic. So really, we only have two more topics. We've got objects and classes and pointers. If you're continuing on in 200, we'll do a deep dive into objects and classes and pointers and spend a lot more time working with these things. So we're going to cover them a little bit here. Nothing super crazy. Again, a couple of the course objectives eventually we're going to look at is analyzing requirements via UML use case and activity diagrams. Once we get to classes, we can really do this sort of thing. Doing it before classes is not very interesting. Recursive procedures, we did real briefly, right? That's a function that calls itself. You'll take a deep dive next semester in that. Small programs in a modern programming language, C++, still pretty modern. We keep updating it. It's got some cool features. We'll edit, compile, and execute programs using an integrated programming environment such as MS Visual Studio. I love Visual Studio. For those of you using Xcode, I'm sorry, but Visual Studio is fantastic. We love it. And the ability to use a program such as MS Visio to draw UML activity diagrams. Again, sort of analyzing things and then actually drawing our own up here as well. So we'll get into that. This will be part of the final project. We'll be turning in pretty pictures as part of your project, which is fun. Really, pictures really are worth 1,000 words. I don't mean to put it down with being silly about it. Uh, Having a way to communicate what is supposed to happen in a picture is very easy for people to understand in a standard format. And this UML is a unified modeling language used lots and lots and lots of places around the world. So pretty standard. So we're getting there on our topics, right? On 12.4 and 12.6, I have no plans to talk. I'll just be around and answer questions for the final project. Again, you're welcome to work in pairs on this. You don't have to, but if you'd like to pair up with somebody, go for it. There's a couple things I have to show you in Git to make sure you don't mess things up. Uh, if both people change the same file and then try and commit to the cloud, it gets a little confused because it doesn't know which version was the correct version to use. And then you have to tell it which version you want it to use. So it's not too bad. Uh, but we'll talk about that a little bit for anybody who wants to work in pairs there. And then hopefully we can get it done around then with enough time. We won't do too much in lab for pointers that day. So a lot of that lab time on 12.4 will be for the final project as well. So ideally you get it done, knocked out of the way. If you want to work ahead on Thanksgiving, that'd be good. Uh, and then on 12.11, instead of taking a final exam, you all will get up here and present your final project or whatever room they assign us. TBD. I don't think they have assigned rooms yet. That's usually like the last week. So you'll have a turn to talk, go over your project, show us your code, maybe answer a question or two. It takes 5 minutes, maybe 10 tops. Please don't make a PowerPoint presentation. That's not necessary. The idea is in the industry, you're going to show people your code. So like, hey, this is what I wrote. Here's how I did it. That's what you do, right? To show your team essentially what's happening here. Similar idea with this. So, questions, thoughts, concerns about the last couple things of class? Believe it or not, we're in the home stretch, and it's only November 6th. Okay, cool. So on the 11th, maybe it will be a month out. Maybe then we'll have more questions. So cool. We're doing pretty good. So arrays and vectors. So we stopped at two-dimensional arrays. We didn't get to this part. We're going to save it. We talked a little bit about the C string stuff, super weird. Oh, your midterms. I wanted to talk about that too. Overall, everyone did pretty good. Pretty happy with the midterms. Uh, should I click the right button here? There we go. A couple questions, because I wrote them, came out a little funny. So most people got points for them. So this one was false. Right? You can't name it anything you want. You can't start with numbers, and you can't use reserved words. Right? You can't name a variable double. So as long as you give me some reason why it was false, it was fine. You didn't have to give me every reason, but just not true. Right? False and some reason why. This one I felt mean about. So technically, this is false because it does not give you a decimal remainder. Right? It's the integer remainder, but that felt mean after looking at everyone's answers. I think people just thought I was wrote the wrong word or wasn't paying attention or whatever happened to be. Maybe a trick question, but not. I felt bad about it. So everyone got points for this, right? But it gives you the integer remainder, right? Not a decimal remainder, right? Or the decimal as the remainder. I don't know. Like so, maybe it's just worded funny because I write things funny. Uh, this one here, I was surprised a couple people got this wrong because we did this one a couple times, right? You get the same sequence every single time, unless you give it a random seed value based on like your clock time. Then you can get a more of a pseudo random series, right? All you had to do was run it. You had Visual Studio, right? You could have ran random a couple times if you wanted, but for that one, this one here, I mean, most everyone did great. I think the people who are not coming to class and just not watching the videos did not do very well on this one. I don't take attendance, and I probably should, so I could like correlate that sort of thing. That's just my hunch. You cannot replace if ifs with switches, right? Because else this can have lots of logic there. You can say, hey, if a number was within a range, or if this is true and this other thing is true, you can't do that with switches, right? I think we looked at your grade. If you want to write out 100 switch cases for your score is 100, your score is 99, your score is 98, you can do 1 to 100, but you're not going to do bigger things, right? So, right, you guys all knew it. Sorry. So yeah, this was false. But switches you can always replace with if else ifs. The other way works fine, right? Definitely, that's fine. Uh, this one I thought was a little funny here. Technically, it's true, right? The for loops and while loops are completely interchangeable because remember, for loops, the items in there are optional, right? So you could say for just nothing, and then your test here, number less than 10, and then nothing. It's a while loop now, right? Right. If you wanted to put some things in here, like int number is 0, and then number plus plus. Sure. Now it looks more like a for loop, but we could also do that with a while loop, right? We could have int number equals 0, while number less than 10, right? Your loops and then inside of here. Okay, sorry. If I'm just shout at me if I should just go on. Sorry, you guys look bored. That's not worth just going over for a minute. Um, Kudos to the few of you who said that's nice of your opinion, Eric, but you're wrong. Perfectly fine. I respect that. If you like break and continue, you are welcome to use them. They irritate me. So that's why and someone even put in here, I feel like this is a trick question. And I felt a little bad. Uh, I don't like them. They do have great uses, right? They're valid. I just don't like them. So I'm going to avoid them. So maybe these should be avoided is the piece. They're like, nah, just because you don't like them doesn't mean we shouldn't avoid them. So pretty much everyone got points for this one. Two reasons to use functions. We did lots of that. Path by values default. Yep. Can return a single value. Some people said true here, or false here, and I didn't know why. I didn't understand why they thought they could prefer more than one thing. If you pass things by reference, you're setting values. It's sort of like returning more than one thing, but you only ever return one thing. And no one like said, "Oh, when you return things by reference, it's like returning more than one thing." They just said, "No, you can." And I was super confused by that. Right? You get to pick one thing. It's an int, it's a double, a string. Later we can return vectors, but it's a single thing. Right? Now, technically, a vector holds a bunch of things, but you're still returning one thing. So I was confused by that one. Um, Default values. I think people just didn't read this one well. Maybe they're rushing through. Time limits do weird things to people. But some people said, "Yeah, this is true." And I was confused because if it's a default, you don't have to give it. Um, anyway, um, most everyone got my answers to this. Maybe a third of people came up with their own. I think they were just googling stuff. Not sure. You open it, you read or write it, and you close it. Is what I was looking for. A lot of people had a couple other things, so that's fine. Like make sure it actually opened. Yeah, that's a good step too. That's fine. Um, yeah, by default we overwrite our files. That was if we just did like that week of, right? And then using absolute paths, we just did this, right? And we didn't have to use absolute paths. So those ones where I was confused if people got wrong as well. Probably people just not watching the videos. So it's good for you to come and listen sometimes, I guess. Hopefully you find it worth your time because you're still coming. So maybe I'm preaching to the choir. Do you want me to do any of the short answer ones? I think these are all pretty straightforward. I'm happy to do any of them. Okay, you're good. Yeah, everyone did pretty good on these. I was pretty happy. So those should all be scored for you. Again, your self-assessment scores I got to enter here. I'm sorry for projects. Most every time, everyone gets their points. Right? You're giving me the screenshots. I can see your code. So unless you just flat out didn't do it and said you scored full points, right? You're going to get your self-assessment score. You guys did great. Um, I got some of the labs in. I got to get some more of the labs in here for you too, but we're doing pretty good. The Ticketmaster project working on. We've got another week, right? Is that a week from today? Yeah, a week from today for the Ticketmaster project. Right? You want to talk more about this one before we jump back into arrays? How's this one going? Oh, and I organized things finally. I didn't have them set up to match the syllabus grading schedule or like how everything's weighted, so it should be in here now for you. Sorry about that. Right. So when you add the show, it's a new file with the name of that show. Probably add the txt if you want. Right. It's optional. You don't have to. Um, you could add .bob if you want, and all your files can be Bob files if you care to, or .eric files if you like Eric files. Right? Doesn't matter what the extension is. It's just if it's a txt, your computer knows what to do with it. Your operating system knows what to do with it. So use the name of the show as the file name. If it exists, tell them, oh, you're already selling tickets for this show. Go back. Like otherwise, we're going to overwrite your file. Probably a bad idea. And then the people who purchase tickets will be really sad at you. Right. So don't let them do that. Um, Figure out how many tickets they want to sell for the show. Hey, I've got 200 tickets for the new Trolls movie coming out. My kids are super excited for the Trolls movie. Kind of excited for it. Right? They're getting the whole band back, right? For the Trolls movie. Aren't you guys excited? No. Okay. Maybe it's my girls are more excited. And that many number of blank tickets where you just have the ticket number, like, hey, here's seat number one, ticket number one. Here's seat two, ticket two, up to 200. So 1 to 200 tickets, right? No name and zero for the confirmation code. That's how we know that they're blank. So ticket numbers, think of that like your seat number, right? If you're selling one of the Taylor Swift concerts, you're going to have 50,000 lines in this file here. Sure, that's fine. We're just going to write it all to a file. Not too big of a deal. Okay. Then when they run option two, we're going to go try and find that file. Hey, I want to sell tickets for this show, right? I'm going to be, kiosk mode or something here. Read all the tickets into your vector. We read the ticket name, the purchaser's name, and the confirmation code. So you've got this list of these things into your vector here, or 3 different vectors, or however you want to go about this, right? We've got some options here. And then ask the user or tell them what the highest ticket number is. So if you've got 200 seats, tell them you can buy up to ticket number 200. Right? Don't make them guess that. If you've got 50,000, up to 50,000. Right? Ask what number they want to buy. Check and see if that one's available. The easy thing to check is probably the confirmation code is 0. If the confirmation code is 0, we haven't sold that ticket. Right? If it's not available, tell them to pick again. If it is, get their name. We'll update their name, and then we'll generate a random 6-digit confirmation code between 100,000 and 999,999. And then we're going to update those in our vectors, however we're storing these, right? Probably vectors, right? And then rewrite the file so that I've got it loaded in my vector, and then I'm going to update the file that's on disk. The cheap way, right? We just overwrite the file. Here's all 200 seats again, 200 tickets again. It doesn't matter that only one changed. We haven't got to doing this the cool way yet. Later on, you'll figure out ways we can do like actually edit like parts of files, and really we just use a database anyway. So it's a little bit silly. We're just practicing with some files here, right? And option 3, you run the report. You say, hey, for this show, give me all the tickets that were sold. So you just read the file and dump it out. Essentially, here's the ticket number. Here's who purchased it. Here's the confirmation code. Does that make sense for this one? Right. So five points for creating new show files, 10 for actually selling tickets from the files and updating the files, and then 5 more points for printing the show report. Okay. All right. We got a week. So hopefully that's going all right. I know a couple of people have started asking me questions on it. That's good. So, all right. Let me fire up Visual Studio here. And let's do arrays and vectors. All right. So everything we did so far was here in main. Right? We didn't do any functions yet. So let's write a function, because functions are fun. So what if we wanted to get like the sum of the numbers in a vector? That might be something we do more than once, right? We've got some code we don't want to repeat. That might be a useful function. So probably an integer, right? Sum of values. And if I want to get them out, right, here's my int array. We'll call this numbers. Well, now it's upset. It doesn't like this. Did I put it on the wrong side? Put it on the wrong side. Put it on the wrong side. Okay, numbers. Okay, cool. So we can give it some array of numbers. We'll try and sum it out. Oh, how many numbers do I have? How many indexes do I have before I run out of space? Yeah, we don't know right now. Right? We can do that silly thing where you go find the size of it, right? Can we do size of in here? Do that somewhere in here, right? Number size. Oh no, that's the vector. Hang on. We did a size of, right? Didn't we do that? We knew it was 4 bytes, and we could find the total size for our array. I really thought we did. I just erased the code because I was like thought that was obnoxious. I probably did that, didn't I? Hang on. I can't remember now. It was last week. Size, values, max, pins, average. Nope. Okay. We don't have it. Let's see. So this was C++ values in array. I think this one was fine. Nope. How to find. This one our hit. Size of operator. There we go. Look at it. It's even giving us code here. That's so fun. Bing chat. They're hyping their AI stuff, which apparently is really expensive to run. I don't know how they're like subsidizing this. I guess they have a lot of money. So you get the size of your array divided by the size of the thing at your first position. And here's more fun syntax. If you know what values are in your array, you can declare them up front. We're about to do that when we get to 2D arrays. So we can figure out the size of the array. Right? So the size of, or it would be total values, right? So int number values is the size of my numbers divided by my size of numbers at 0. Right? So this is how many bytes does this one take divided by how many bytes does the first one take. Right? Because we store X number of values. It should be that size. So that's why we start with 0. I drew a picture last week, right? Drew a terrible picture. We started at index 0. Okay, we'll get there. Let's see if we can loop. So for int, index is 0, index is less than number of values in index plus plus. And then we need probably a place to store all this, right? So we'll have an int for the total or sum. Sum is probably better, right? Because that's what we're calling it. Sum is 0. We'll add to the sum our numbers at index of index. And we're done. We can return sum. So if you give me an array, I should be able to go count all the values in it, right? Sum them all up. Let's try it. So here's our array, my numbers, right? Oh, right here. We did this. Yeah. I scrolled past it 3 times and you guys didn't yell at me. See? We did it. We did it. I'm remembering now. Yeah, number of values. Okay, we just didn't use it here because we looked at other options. So once I've got my numbers, let's see. Let's see if we can see out the sum of values in my numbers. Sum of values given my numbers. My numbers. Probably an end line, right? Let's give it a run. Oh, we had a breakpoint. And continue. And continue. Sum of value of my numbers is 20? I didn't actually check. Does that seem right? That doesn't seem right. Does that seem right? My numbers. Why doesn't that doesn't seem right? Let's try it again. Stop and run into debug mode. All right, so my numbers, right? We've got our my numbers array, 7, 13, 21, 9, 5, and 15. So 20, 50, 70 should be the sum, right? Sum is 70. Okay. So let's step into our function here. And now we've got numbers as 7. Not very useful here. Okay, sure. So the number of values we calculated is 2. Well, that doesn't seem right. Size of what? Well, so the variable here is numbers in our function. Right, this is the variable we have for our array. I think 7 was the first value there, right? Somehow we got 2 out of that. How do we get 2 out of that? That's interesting. Sure. So sum is now 7, and it read the next value out somehow, right? Numbers at index of 1. It read out the 13, even though we didn't know it was there. And then the loop stops. So turns out you can't really get the size of basic arrays very well. Doesn't play nice here because C++ is dumb. So we could tell it, number of values here. We could have it for number of values if we wanted, and then we don't need this line here. So if I tell it, hey, I'm going to get the sum of my numbers and I have 6 values, right, this one ought to work, right? So that should give me 70 if we try it. Do we get 70? We got 70 because we told it we've got this many values. But now, what if I typo this, right? What if I say 7 here? Oh, 87, that's even better. What if we say 7? Right? We step. Negative 85, 858 million. Uh-oh. C++ is more than happy to do that for us, and it will do the wrong thing, right? So, again, not great. So, passing arrays to functions is really obnoxious. Really obnoxious. Right? This is no fun. No fun at all. But passing vectors are great. We love vectors. Let's try with vectors. Let's try int sum of vector values. Given a vector of type int, we'll call numbers. Right? Basically the same thing here. Right? Just do a little loop for sum. Well, do you want to use the enhanced for loop? We can do that. Sum is 0. Right? We could say for int number colon numbers. Right? We did these fancy loops, the read-only loops. We did these ones, right? Where you're not changing the value. Didn't we do those? I swear we did this, right? Yeah, we did this. You guys are looking at me like I'm crazy. I feel crazy now. It's been a week. It's been a week. It's okay. It's all right. That's why we write stuff down. All right, we'll take our sum plus equal the number. And we're done. We can return sum. All right, so cool. If I have a vector, let me stop the debugging here so I get my screen back. I think we got a vector down here. This is our lotto ticket, right? We've added some numbers to the vector for our lotto ticket. See out sum of values in lotto ticket vector. Sum of vector values given the lotto ticket. And an end line. Let's try this one here. All right, so step into. Oh, I didn't want that. That's in the wrong spot for the breakpoint. Here we go. This one. So step into this function here, our sum of vector values, or a vector for numbers. Numbers is size 6, has all the correct numbers in here. This code will probably work. Right? We excited? We get our values here. We return the sum, and we're done. So this one worked. Right? Pretty happy? Can you think of why numbers didn't work? It was actually one of the questions on the midterm as the clue to it. It was a fun thought exercise before noon on a Monday. When we pass arguments, what are we passing? Like if I say here's a value for an argument, what are we giving? What does C++ do by default? Well, what does it give you? So it's giving you a value for this variable. What does it give? Right, or my number of values. Right, it passes them by value. So the value of an array is its memory address. Right, we said this is where it starts in memory. Here's its value. Right, because that's its memory address is index 0, and then every one you want to get at, we just multiply the size of an item times that index to read that location in memory, because we get one big block of memory. So if I'm passing by value, my numbers array here, right, I'm passing the memory address. Here's the memory address. Here's where the array is. That's the only piece of information we have for an array, is where it is in memory, like where its address is. It's the exact same thing for these arrays. Like when I have my numbers, it doesn't know how big it is. You can't ask the my numbers array how many items it has. Thankfully, we can get the size of it here. And now in this part of the code, it knows what the size is correctly because it has that reference here. It knows we sized it for a specific size. Once we pass it by value, here's your memory address. All it has is the memory address. It lost all the other pieces of information around how many items it was supposed to have. Right? So we pass a vector, we're passing it by value. Right? Let's see if we can change number here. We'll do for index is 0, x is less than numbers dot size, x plus plus. So we'll take our sum plus equals the numbers at the index, and then let's just mess with that value for fun here. We'll take numbers dot at index, and how about we take one away? I don't know, just for fun. Take one away. See what we get here. So let's run this. Don't want that breakpoint. Don't want that breakpoint. Here we go. So we're at my numbers vector, right? And we've taken one away from all the values. Right? We had a bunch of odd numbers. Now we have a bunch of even numbers, right? So we went through, we were able to do the sum, 36. That's what we got last time. We took one away. So this numbers vector is what we were working with, right? That's our type of it. Now we come back from our function. We have our lotto ticket. The lotto ticket hasn't changed. Right? We didn't change the original. Because what do we pass when we call this function? When we call sum of vector values, we passed this by value. We didn't pass the reference to it. So when I was changing it, I wasn't changing the original, I was changing a copy. Because I passed it by value. I had a copy. So if you want those to change, right, we can say, hey, give me a reference to your vectors. This is much faster, right? Because depending on how large your vector is, whatever we're doing here, I might have, 5,000 seats in my vector. If I pass it by value, I now have made a copy of those 5,000 seats. Our computers are quick enough. You're not going to notice. Like even at 50,000 for a Taylor Swift show, you're probably not going to notice that it has to copy the vector. But it had to copy it, right? Work had to happen to do that. So if we pass it by reference here, and then we go and change our values, right? So we've got our numbers vector, right? We subtracted one from all of our values. We're done with the function. Now if we take a look at our lotto ticket, now the lotto ticket's been changed. So same idea. If you pass something by reference, you can change its you can change the values there because you know where it is in memory. If you pass by value, we're getting a copy. The problem is with arrays, the value of an array is its memory address. So a basic array, like my other numbers here, its literal value is this x000007DDD96F2D8. That's the value of the variable my other numbers. I can make a copy. It's still the same memory address. I can pass it by reference. You still have the memory address, right? One way or the other. Because the value is the memory address. It gets a little weird. Okay, it's going to get weirder when we get to pointers. Don't worry. C++ is nuts, but it's really powerful. You can do some fun stuff with it here. So let's have a little bit of fun and use some tools in Visual Studio because Visual Studio is amazing. And I love Visual Studio. So this sum of vector values, I'm going to take out the pass by reference here. We'll take out the reference. So we're going to get a copy. So let's go and make a vector of type int here. This is random numbers. And with vectors, you can pre-size it. So I know I'm going to put a bunch of things here. So let's do like 100,000. Can I do? I think I can do underscores, right? Can I get away with underscores? No. Was it comma? What character? I can put commas in here? I think it takes commas, right? In literals? This was like way back in chapter 2. I don't remember that far back. And we can say for int number 0, number is less than 100,000, number plus plus. We'll take my random numbers vector, and we want to push back random, just a random number. Oops, equals 0. I think this one works for us here. Let's give it a try. Should be able to get 100,000 random ones. Only size to 100. Maybe it doesn't like the comma. Maybe the comma's bad. What am I doing here then? I thought there was a delimiter we can use. I don't remember anymore. That's why I checked. All right, so we'll go less than my random numbers dot size. And instead of pushing back, right, if those indexes exist, if we pre-sized it, I can just say at the index, right, equals rand. Instead of pushing back, oh, it's this index here. Index. Okay. So this will size it 100,000 empties, right? See random numbers is really big. We can scroll through and see all the zeros if you want to scroll. It's really boring. Then we can go and assign a bunch of numbers. So we'll continue on. And now our random number vector has a bunch of random values in it, like we'd expect, right? So what we can see over here, this little part of the window we've never really looked at here is fun. This is your diagnostic tools. So we want to see our memory usage here. Why did it pause? It paused on me here. Hang on, what is it? Output? No, I don't want that one. Zoom in, zoom out. Should be able to see how much memory we're using here in a second. I have to continue? I think I have to continue. Okay, so now it's waiting here. Okay, so now we can see we're using, is that 1 megabyte of memory? Does that seem right? 1 meg? This is not behaving like I wanted it to. Usually this is much better. So 100,000 values times 4 bytes for integers. So that's 400,000 bytes. It's not very much, right? Because kilobyte and then megabyte is 1,000 of those. So we've got 1,000,000 bytes already, and we only have 400,000. We don't have a whole lot yet. So let's go bigger. Let's go bigger. So if you do 1,000,000 here, right, that should be about 4 meg of memory, 4 megabytes, 4 million bytes or so. Let's try it. So we take the breakpoint off and continue. Take my breakpoint off and continue. Continue. Oh, now we're at 100? 5. There we go. Yep, right around 5 or so of all the things we're storing. That's not so bad, right? All right. It took a second to catch up here. So if now we were to make a copy of it, right, we should see that change. So the sum of vector values, if we're passing by copy, and we have 1,000,000 things, let's see how fast it is here. Right, so we make our vector, and then we can see out the sum of a bunch of random numbers is sum of vector values given random numbers and then line. Now, the problem here is we have an integer, and I don't think that's going to sum about a million random numbers without overflowing the integer value, right? So we probably need something bigger than an int here, right? What do we need? What's bigger than an int? Should we go back to Zybooks? It tells us, right? We want numeric data types. Look at that. We can go use our resources here. Should we use a long or just a long? Because ints, yeah, it's got to be long, right? Because ints are already 32 bits. So long should be big enough, right, to get 9 centillion. Is that what that was? Like millions, billions, trillions, quadrillions, centillions. I think so. Sounds right. So let's try that. Let's do a long, and return the sum. See if that works for us. All right. Let's see if it catches up on how much memory we're using here. Come on. Wakey, wakey. Is it going to do it? Do I have to pause somewhere? My goodness. This should just work. Memory usage. I want enable snapshots. Okay. Take a snapshot. Look at that. We can look specifically at how much memory we're using. No. All items are filtered out of the view. Reset my filters. I'm not filtering anything. This is not playing nice. I'm sad. Come on. Let's step. When we did our sum, it should have doubled our memory. Why is the tool not working? Take a snapshot. Aha. All right, so now we're up some memory. So here's in our heap memory, all the things we're storing here. This is fun. A bunch of things in here. It's not giving us our array. That's okay. That's all right. But eventually you can see how much memory you're using. I'm not doing something right here. Because it's paused. There it goes. And it went back down. I have to put a C in? That's silly. It's been a little while since I played with it, sorry. But it should tell us how much memory it's using. That's the fun thing. We should be able to see it double when we hit that point. Let me try one more thing. So that was not behaving. Let me try Task Manager. So terminal, let's see, is this one it? Is Visual Studio? Okay. So Visual Studio is using a bunch of different pieces of memory here. Console window host. I think that's probably the one that's doing it. Or chapter 7, arrays and vectors. So this is the program we're running, right? We run our executable. This is totally worth it, I promise. It's very exciting. So here's the executable that's running. It's using about 4 meg of memory right now. So let's step into our sum of vectors here. We're passing our vector. We see it's using 8 meg. We've doubled our memory usage there. Okay, we can show it in Task Manager, even if our process tool over here is not cooperating. Memory tool is not cooperating. So because we passed a copy, right, we had to restore all those things in memory. So with a million ints, not taking up very much space. So I think you'll be fine passing by reference or passing by value. Should be okay, right? But if we do pass by reference here, we change that, and then we run it. Go back to Task Manager. Open up Visual Studio. 4 meg. Step into our function. We're in our function. We're still at 4 meg, right? Because we said, here's the memory address of the vector. You don't have to make a copy of it. But now someone can go and modify the vector if I'm not careful, right? That's where we can add in like the constant operators and things we looked at before to say, hey, I guarantee I won't modify it. Please just give me a copy. These sorts of things. So that was fun. All of that to get to see we can use a lot of memory or not use as much memory if we're making copies. Okay. You all right so far? So again, passing arrays does not work very well. You can pass the size of them, and you can make constants, and you can do things like that, but it doesn't work as well. Right? It's not as friendly. Where a vector, you're like, here, go for it, and the vector will tell you how many items are in it. So another reason vectors are amazing. All right, should we make two-dimensional arrays and vectors? So the idea with a vector, right? Pull up Word here again, right? We can draw a pretty picture. Pictures are fun. We said a vector was like, here's a big chunk of memory here, and you can store a couple values in it, right? So we'll store 5 values in this one chunk of memory. Here's index 0, index 1, index 2, index 3, index 4. That's a regular vector, that's a regular array, right? With a two-dimensional vector, each item here is another vector or another array. So it gets a little hard to write it then. So what we usually do is say, okay, here's the first value is going to be another array. Let's say this is size 3, right? So the first value at index 0 is another array or another vector with 3 indexes, 0, 1, and 2, right? And then we'll say the next value in here was another array or vector of 3 values. And then the third value was another one of 3 values. And then that whole array or vector is done. So you kind of think of it as rows and columns. It's not actually rows and columns, right? It's just one row, essentially, with a bunch of things in it here. But it's easier for us to think of as rows and columns. Because then we know we have row 0, we have row 1, we have row 2, or row index 0, row index 1, row index 2, right? That's the first value in the outer vector, or the outer array. And then each of them has its own values. We kind of think of those as columns, 0, 1, and 2, right? So if we were to play tic-tac-toe, you could tell me, hey, 0, 0 is this one over here. You could go X. You could go 1, 1. You could do an O over here, right? You could do those sorts of things. So let's practice real quick. Let's try tic-tac-toe. I'll let you guys go first. And if you beat me at tic-tac-toe, you get an automatic A in the class. Full stop. Just you pass the class because you beat me at tic-tac-toe. So go for it. Try your best. So where do you want to go? Where? So you got to use the coordinates. What row and what column? So like 0, 0 or 1, 1, 2, 2. Any comment? Like which one? 0, 0? So this top corner? Okay. So I'll go in the middle. 1, 1. Yeah. So 0, 1, you're going to go up here. So row 0, column 1. So column 1, I'm sorry, row 1, column 0? Yeah. Sure. Okay. So then I'll go to 2, 0 to block you. You want 0, 2, right? You want row 0, column 2 to block me. So then I'll block you at 0, 1, and you're going to come block me at 2, 1. And then either one doesn't matter for me. I'm going to go over here because it makes a cool pattern, and you can go here. We tied. Cats game. Can we play again? Sure. It just FYI, it's impossible to lose a tic-tac-toe. To lose. Yeah, so it will always be a draw. Unless I beat you, but you will never beat me at tic-tac-toe. Where do you want to go? 0, 0, top left again? Okay. I'll go in the center. 2, 2. Okay, so you're going down here. All right, this one gets a little trickier here, because now I need to force you into a move here. So I'm going to go, how about row 1, column 0, to force you to come over here. So you're going to go row 1, column 2, right? To block me. Then I have to go row 0, column 2 to block you, and then you have to go stop me at row 2, column 0. And then I have to stop you at row 2, column 1, and then you go up here and it's a tie game. Very exciting. It's impossible to lose. My kids didn't believe me. So my son actually did beat he's 16 and very stubborn. Bless him. He's a pretty good kid. After about 30 games, he finally got one on me because I was like trying to deal with his little brother and not paying enough attention to the game. He was so proud of himself that he finally beat me. I was like, all right, you got to pass my class. It's like, aw, but just stop them from winning. No, if you play against someone who knows what they're doing, you cannot beat them. It is impossible. It's not Connect Four. If you go first, you can always win, guaranteed. So Connect Four is not a fair game, which is it's really unfortunate. And kids hate it when you beat them every time at Connect Four. Right. My wife says I should let the kids win sometimes. So I feel like that's not fair. You're supposed to let kids win. Like it doesn't happen in real life. Like no one lets you win in real life. Don't you have to prepare them for real life? Well, you got to learn that now that you got to lose gracefully. I'll give them odds in chess, like because you can give out odds in chess, and like then it's a fair game, right? If they have queen odds or something. But um, other than that, like games of just skill. Okay. Anyway, I'm a little crazy. I'm sorry. So this is a two-dimensional array. So let's see if we can make a two-dimensional array for tic-tac-toe. Right. So we want a vector of what type? What are we storing in this vector? Are we storing integers or characters? What? What value? Well, we're not doing integers, right? The vector has a bunch of what inside of it, right? What do we have? This was our vector, and what was inside of it? We had three things inside of this outer vector here. What do we have? No, another vector, and another vector with probably characters, right? Because we did x's and o's. Yep. So it's a vector of type char here, and that's our board. This looks super weird, but it's cool. Right, and then we can push back a vector of type char. We want, hang on, we want 3, right? If I size it to 3, is that going to size it to 3 for me? 4 dot at 0. So then we're going to set that, right, equals to a vector of char. Is that it? I think that's it. So we can do a little loop. So for if row is 0, row is less than 3, row plus plus. We'll take our board, map the row, set it to a new vector of char. Those should be size 3 as well. So let's see. So when we build out this vector, when we start here, we're going to say I want 3 empty rows, right? So our board here, right, is 3 empty vectors. Okay. And then we can go, oh, we'll set them here as size 3. There we go. So we set size 3, set size 3, size 3. So now we get our default characters here. So now we're sized up, right? So maybe then we want to go through and put in spaces instead of that default character. So vectors are a little bit annoying sometimes to go through now. Now that we have it, we could say for int column is 0, column is less than 3, column plus plus. So we're going to do a loop inside the loop, and I can say my board dot at the row is another vector, dot at the column, column, column. I'm sorry, dot at the column here, column. I can't spell. Equals, let's put a space in here, right? A little space character. So we'll have an empty board. Okay, so we'll go through, set 3 rows. Each row will have 3 columns, right? Another vector with 3 columns, and then we're setting. So in the loop here, when row is 0, column 0, we're going to set 0, 0 to a space. When row is 0, we'll have column number 1 is a space, column number 2 is a space, and then we'll go back. Row becomes 1. Set column 0, 1, and 2 to space. Row 2, column 0, 1, and 2 to space. Right, so we're going to set them all to spaces. Sort of a tedious way of going about it here. I think there's a way. Plus initializer. Do we have a better syntax for it? This one. Can I do that? Yes. Okay. So in later versions, we were in like 18 or something like that, or 20. Oh my goodness, I should know. I don't off the top of my head. we can use this curly brace syntax, which is much nicer. So we can say, instead of this equals vector of char3, we should be able to give it here. Oops, where do we go here? I'll leave this one here because this is like probably the more classic way to go about it here. We might be able to say board is curly brace, space, space, space. So there's one row, right? Comma. So imagine here's each individual value inside of the board, right? We're setting, and we're setting. So this we'll do vector of type vector of type char. How about the easy board and a semicolon? Right, so this is a little easier if we know what's going in, right? To use this initializer, I know what the values are, rather than here's a bunch of empties, right? Because we can loop through, we can make 3 rows, we can put 3 columns in each row, right? Or 3 values in each row, and then set them, or we can just hard code some values in here. So that works out pretty well, right? So now we've got our board, right? Now we know whose turn it is, right? So the char, I don't know, current player is going to start off. X always goes first, right? We'll have X go. Okay. Then how do you play tic tac toe? Like if we were just thinking about this in English, like if we're to try and if we're going to turn it into code soon, so what steps do we have here in English? How do we play tic tac toe? We got our board. We know whose turn it is. What happens next? Okay, so get a move. All right, and then what? Okay, next player, and then what? Get a move. What next? Next player. What's next? Get a move, and then what? Next player. I feel like you're missing something here. Yeah, to see if someone won, right? See if there's a game over, right? So like, while not game over, I mean that's a little bit less Englishy, but like as long as the game's not over, get a move next player, and then like we just don't need to repeat all that, right? Is that how you play tic tac toe? You while the game's not over, get a move, and then go to the next player. If it's not over, get a move, go to the next player. It's not over, right? That's sort of the flow. Okay, cool. So, well, while not is game over, and then we're going to give the board to our function is game over. Right? We'll make a function called is game over. Right? So to get a move, that one's a little trickier, but how about we just say make move? Right? We'll make a function called make move, given the current player and the board. Make a move. Okay, so we can make a function for make move. We can do that. And then next player. Well, how do we know whose turn it should be? Hmm? I have a current player, so I know who the current player is. Yeah. Yeah, so how do we change current player to the next player? So current player equals O, like that. And then O always gets turned. Right? How do we make sure we change from X to O or O to X? I'm sorry? A chart? Oh, a char. Yeah. Yeah, that's a char. Right. We need to change the value of current player. Right. So we can't always put it to O though, because it's not always O's turn. So you do for the same while we could do
so that the current input is X, then the next input is O, and then it goes back to X. No.
Well,
Right.
so we have to change. How do we change current player? Right? How do we know which player it should be? Well, so it starts as X, and then X makes a move, and then it should be O's turn. O's make a move, and then it should be X's turn. So we need to flip back and forth between O and X. Well, we're in a loop. Yeah, yeah, yeah. So if the current player is X, then we're going to change current player to O. If it's not X, then we'll change current player back to X. Right? You can use one of those fun ternary expressions if you like. That's how I know most people find their solutions online when they give me ternary expressions. No one uses them, right? You could say current player equals, what is it? Current player equals X question mark O colon X or some nonsense like that. Like I I have to remember them every time. I hate that syntax, but right. Remember these? We looked at them real briefly, and I said this is how I know people cheat because they gave me this garbage. Someone gave me this on the midterm. It was sad with no citing their source. Like I even told you, like the first day of class, and like when we got to these things, like I'm a little dumb. I'm not gonna lie, but some things are easy. So yeah, I would just do it this way, right? If it's X's turn, now it's O's turn. If it was not X's turn, now it is X's turn, right? And we just keep playing until the game's over. Is that it? Right? Why not? Okay, so let's do is game over first. So is game over is going to return a boolean, right? It's either yes or no, true or false. The game is over true or the game is over false. So that's a boolean type bool type function here. Is game over given a vector of char board, and again probably by reference, right? Doesn't really matter because it's really small, but probably a reference here. Or we can even say what a constant reference, right? If we want to say we promise we won't change the board on you, we got options here. So how do we know if the game is over?
How is it on the space time?
Right, so that's a tie game. So turn is game tied given the board. Right, so that's one way it's over. What else could how else could it be over?
There's three in a row.
Okay, or it's three in a row, or it has three in a row, or three in a row given the board. Right, if it's either tied or there's three in a row, the game's over. True, true or true. Right, the only time I'll give back false is if they're both false. It's not tied and there's not a three in a row. Okay, so far, right? We're doing functional decomposition. You guys are excited. You're going to use that term at your Thanksgiving dinner, right? And record it for everyone so we can see everyone's face. And they're like, you nerd. All right, so Boolean, how about is game tied? Given a vector of 4. I'm just going to copy that because that's tedious. So how do we know if it's tied? You said if there's no spaces, right? So let's go loop through. So I can say for now I have rows and I have columns, but what I really have, right, is one vector, a vector of vectors. So as I loop through the board, I get a vector of characters. So for vector of char called the row in the board, right, I get each row out. Then I can loop through each character in that row or each column, right? I can say for char, I don't know, spot, column, right? I guess in column in the row. This is the enhanced for loop. Like this is my little read only loop shortcut here. I can go through and say, okay, if my column is equal to a blank, return false. It's not tied because I found a blank. If I've gone through every column and every row and I haven't returned a false, I can return true. It must be tied, right? Because we're out of spaces. Okay. So the other way to write this, then you might see, right? If we're practicing using our indexes and stuff, we could say for int row index is 0, row index is less than board.size is probably proper. I know it's 3, but this is, we're practicing proper for things here. Row index plus plus. And then for int column index, 0, column index is less than. Now this gets a little weird. I know it's 3, but the proper thing here is board dot at the row index dot size, right? How many columns are in the current row? Because maybe we want to make a crazy tic-tac-toe that's a 3 by 5, or one of the rows has 5 columns here because we just drew the board wrong. Because when my 6-year-old draws a board for Connect 4, it's crazy. Or tic-tac-toe, it's crazy sometimes. If she's not paying attention, it just draws a bunch of lines, right? However we want to do it, right? And then we'll take our column index plus plus. So to get at an individual row like we were practicing, I'd say if my board dot at the row index dot at the column index. That's the individual character at this row, at this column, right? Here's row 0, here's row 1, here's row 2, here's column 0, column 1, column 2, right? I'm just looping through. For all of row 0, do column 0, 1, and 2. For all of row 1, do column 0, 1, and 2, right? We can do by index. If that is equal to a space, return false. Otherwise, return true, right? Same thing here, right? Either the enhanced loop or the more verbose at notation. Both do the same thing here, right? Okay, so that's our game type. How about 3 in a row? 3 in a row is a little trickier. So Boolean 3 in a row given a vector of something board. Okay. Now, before we actually figure it out, how many different ways can you do a three in a row? You can do them horizontally, you can do them vertically, and you can do them diagonally. Okay, so let's do that because those are smaller problems for us to solve. So we're going to return 3 in a row in a row horizontally given the board, or 3 in a row vertically or 3 in a row diagonally. Right? How about that? Can we break it into those? Because those are smaller problems for us to solve. Functional decomposition. You're going to love it. I promise. You're going to love it. All right. So a Boolean for 3 in a row horizontally, given a vector of char board. Okay, so if we're only care about horizontal, I'm going to look at each row here then, right? So now I can loop through either the enhanced for loop or I can use the index notation. I'm going to skip doing both because we're running short on time here. I can do this sort of loop here, right? And say, okay, for every row here, let's do something, right? For every row. If my row dot at 0 does not equal a space, because if it's a space, I don't care. I don't. If it, there's no winner here, right? So if it's not a space, right, and then my row at 0 is equal to the row at 1, and my row at 0 is equal to the row at 2, right? If it's not a space and they match, 0 and 1 and 2 match, then someone must have a 3 in a row, right? If that's all true, I return true. If I've gone through every row, all 3 rows, and I haven't returned true, no one won horizontally. I can return false, right? Okay, that makes sense. How about vertically? Vertically is a little different here, right? So we're going to say for int column index is 0, column index is less than, again, 3 or board size. It doesn't matter too much or other for tic-tac-toe, column index plus plus. So we're going to check each column at a time. I'm going to say, hey, if my board at 0 dot at the column index, right? So at row 0 at the column index. So for column 0, I'm going to check row 0, row 1, row 2. For column 1, I'm going to check row 0, row 1, row 2. For column 2, I'm going to check row 0, row 1, row 2. Right? So this is always row 0 if that is not a space, right? And it matches. This one matches column 1, right? And where's my and here? And 0 matches 2. 0 matches 2. Right? If all of that is true, return true. Someone won vertically. If not, return false. They didn't win vertically, right? So for each column, so at column 0, check row 0, 1, and 2. Go to the next column, check 0, 1, and 2. Go to the next column, check 0, 1, and 2. For using a lot of this index notation. Lots of fun. Okay? So we did that one. How about 3 in a row diagonally? This is a Boolean 3 in a row diagonally, given a vector of vectors of characters here. So this one, there's 2 diagonals, right? I've got 0, 0, 1, 1, and 2, 2. And I have 2, 0, 1, 1, and 0, 2. Right? We could make it into 2 functions. At this point, it's probably not worth it. Right? So I'm going to say, hey, if now my board dot at 1 dot at 1, this is the center, does not equal a space. Right? That's the center. If the center is a space, you can't have 1 diagonally. Right? That's just a guarantee. Right? So if it's not a space, and then does it match? Does 1, 1 equal 0, 0? 0, 0, right? And does 1, 1 match 2, 2? 1, 1 match 2, 2. So this is true, right? So this one and this one, or I'm going to check the other diagonal, right? The center's not a space, and 1, 1 matches 2, 0, and matches 0, 2, right? So the center matches 2, 0, right? Row 2, column 0, and then the center matches row 0, column 2. Row 0, column 2. Oh, no, 2 zeros over here. Row 2, column 0. Row 2, column 0. This one matches, 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 right? If either of that or that is true, and the center's not a blank, we can return true. Am I running out of parentheses? Where am I? I don't have enough parentheses here. Hang on. That one there, that one there, that one here. Right, so this one or this one, right, with all of this anded together here. So this is 1, this is 1. We have this and this or this. It's a little messy. Return true, return true. Maybe this would have been better as 2 functions, and I'm crazy, but I think we'll be okay. If we didn't return true at the end of that if, right, return false. Now at this point, if you're saying if something's true, return true, just return it. Right? Save yourself the hassle. Just return that thing. It's a little ugly, but that is what it is, right? Because if you say if true, return true, just return it. It's already true. Right? Save yourself a little typing. Now this is a little error prone here, right? We probably want to clean this up a little bit here. Because that looks a little crazy here. There's my that one matches that one, right? And then this one should match that one, and then that one, and then that one. I don't think we need that last set then. It's probably okay here. Right? Any way you want to group these things is probably fine. Like we can make it more visual if we care, but it's probably okay. All right, anyway, that's our game. Right? Oh, we need to make move. We're almost done. Oh, we got 2 minutes left. Can you make move? Void make move. Given we said the current player on the board, char current player, and a vector board. Now this one is important. We have the reference, and we're not going to be constant here because we do want to change the board. Right? We're going to make a move. We're going to change the characters on the board here. So we need to get the input, what row, what column, right? So int row, int column. Goodness, separate lines. See, we have to print the board. Okay, we're not going to make it here. We'll be able to finish this up on Wednesday. We're close though. We're real close, right? So what do we have to do? Print board, get row and index, check for valid, mark board, right? Those sorts of. So we got a couple steps. We're close. All right. So 2-dimensionals, lots of fun. You're going to do lots of things with 2-dimensional arrays and vectors. It's a little crazy with the syntax, right? We just got to slow it down and think about each thing, right? The board is a vector of vectors. So board at an index is another vector that I can then get another index out of. Right? Again, we like to think rows and columns. That sort of helps with our head. So add is the first row. The next add is the column. It's sort of the way to go about it here. All right. You folks take care. I'll see you for lab tonight.